Hello friends, in this video we're going to look at this Pansat digital satellite receiver 2100A. It says digital video broadcasting here. Has a simple control panel of power and up and down channels and a 4-digit display. I previously plugged this in and tried it out and it seemed to nominally work, but the fact is that this is an obsolete unit and I bought it for salvage. In particular, I wanted a speaker connector which was on the back of it. I paid $5.99 for it at a local thrift store. I've already taken out some of the pieces, so the box here is partly empty. We'll show you the pieces separately. But let's start with the power supply, which is still in the box. So we've got a power cord here, an overall power interrupter switch here, which stops the flow of kind of an ambient current that it takes even while it's supposedly off. So this has kind of a standby mode. From some research I've done, it had a remote control that came with it. This unit didn't, so I don't have that. This is an obsolete unit that doesn't seem to have any real value to much of anybody, and since I bought it for parts and didn't pay much for it, that's what I'm going to do with it. One of the interesting things about this power supply that I haven't really seen before is it produces a lot of different voltages with a kind of a combination of what I'd call switching power supply and linear power supply techniques. So on the front end of this we've got the earmarks of a switching power supply. There's some big choke here. This is a choke around the power cord, which is just a ferrite core that the power cord is wrapped around inside this heat shrink. So large capacitor. And this is a transformer of the type you typically see in switching power supplies. It's fairly small, and topologically it looks like this is divided into two sections, what I call the high voltage section, which is on the line side, and probably some sort of higher voltage at this point if it were on and activated. And then on this other side you'll notice we've got lots of fairly large capacitors, two large diodes that are actually even larger than the two diodes on this side, because these are going to be sort of high current here versus this is higher voltage, probably the wall voltage at this point, and lower current. So that's kind of counterintuitive that the more total power flows through these input small diodes than goes out through the large output diodes. But looking at the markings on the board, this has a variety of voltages on this connector. I won't list them all here, but in the 20 volt range, 3.3, and etc. So this has some interest as a kind of a power supply that can put out lots of different voltages. This front panel as it stands right now is just a piece of plastic with some sort of captive buttons, and most of the real action is going on the motherboard, which I'll get next. Here's the motherboard that I've pulled out of it that goes into this area. So this power connector corresponds to this row of pins here. These are the back panel elements. We'll look at those in a minute. 4-digit display. This is some sort of power light. And these three little micro switches here correspond to the 3 buttons on the front of power and channel up and down. Looking at this board, there's a flash part I'm guessing this is some sort of SD-RAM part, and then a processor under this apparently copper heatsink. I can't tell what the processor is, but you know, I'd have to pull the heatsink off of that. Got everything turned around so we can see, using the back panel markings, what's going on here. We've got antenna in and out, which is these two. So that's some sort of TV interface in effect. We've got IF input and IF output, which correspond to this unit. So this is an IF converter. So the fact that these say IF input and output tells me that this interacts with the antenna probably, or maybe a separate box. We've got RS-232 here, which kind of dates the unit. It's probably at least 20 years old. RS-232 is still used in a lot of specialized applications, but it isn't used in any kind of commercial PC or commercial units like this anymore. So that dates it to a certain era. Here we've got the matching RS-232 connector, these video right and left audio, and 0 to 12 volts. I'm not sure what that's all about, but looks like with this lightning symbol that that's a power connector on an RCA connector, which would be kind of unusual, but who knows. This is a 7805 regulator, which is a 5-volt regulator with a captive little heatsink that goes with that. This is a 7812, which is a 12-volt regulator, and no separate heatsink, so that must not provide much power compared to the 5-volt. If we look at the power supply concept here, it's basically to output several low voltages here. They get further regulated on this board, locally regulated, and there may even be a buck circuit or something that runs the 3.3 volts, or maybe that's heavily filtered. Usually that's generated very close to the processor it's being used on, so that might be here somewhere. I kind of doubt that they take it from here, put it in here, and run it all the way across the processor, but who knows. Here we've got a lot of elements that are kind of working on multiple voltages. Who knows how these are associated with each other, but there might be, you know, 1 or 2 capacitors per voltage output, something like that. See, we've also got some smaller diodes here, so we can conclude that there's multiple voltages coming out of the low voltage side of this switching power supply that are sort of dealt with as linear power supplies, including these regulators on the motherboard. So this is kind of something I haven't really seen before, is a kind of hybrid between a switching power supply on one side and a linear power supply in effect on the other side. Now, that may be that the highest current output of this is truly a switching supply on this side. Like, one thing I see here is this 4-pin IC is typical of an opto-isolator that's used in switching power supplies, and that, as well as the transformer, kind of mark the demarcation point between, if you imagine drawing a straight line right through the middle of this IC and this transformer, that's where our high voltage side is over here versus our low voltage side over here. So from a salvage standpoint, what interests me here mainly is the these regulators are worth the trouble and time of pulling off. A little heatsink I'll probably pull off just for curiosity as far as what's underneath it. It might be some sort of specialized video processor chip or some sort of general purpose microprocessor or DSP chip. We've got this 4-digit display which appears to be self-contained. I might pull that off and maybe try to research what that is, if it's worth putting in the junk box or if it's just of no interest at all. Got a multitude of little can capacitors. I may or may not bother with pulling those off. We've got power diode here that might be of some interest. We've got this quad RCA connector, so that is a good one for the junk box, and this audio connector of some kind. So there's a few little pieces to pull off there. Back at the box here in the chassis, we've got, let's say we leave the power supply intact. The box, including its lid, might be worth saving as a project box. Let's say we add some things in here in conjunction with this power supply. So this is potentially a useful project box. And as the last item, I had set aside this little board that has, what I really bought the whole thing for was this 4 element, stereo speaker connector with 2 grounds and 2 hots. This is a super VHS type connector. Don't have any interest in that. Don't have any interest in the board itself, except possibly as a vehicle to hook up to this rest of this connector. I bought this whole unit with the intent of getting this stereo speaker connector, and I was hoping to put that on my Klipsch subwoofer unit in a video that I just published right before I shot this. And on second thought, it turns out it doesn't fit very well. It looked kind of odd. So I may just kind of actually keep that, and I've since kind of revised my plans for the Klipsch unit, so this might be one to just set aside for some other project. This audio connector with its little board I'll probably just leave intact and throw in the junk box, and I can either use that with the wires that are on it, or I can take it off later on if needed, something like that. So to wrap up here, overall I'm happy with my purchase. Got some cool stuff here for $7, so that's a success. We had some fun, we made a video, but it turns out that the part I was buying it for, essentially this, isn't useful to me as I intended, and the part that I didn't know anything about really in advance is this kind of interesting multi-output power supply with a possible project box for future use is kind of worth it as an item to put on the shelf. Taking some of the parts off of this board. This is the little heat sink that goes over the processor. I looked up the ID numbers on the processor and couldn't really come up with anything, so I think that must be some sort of highly custom processor just for this job. Here's my little assortment of parts that I pulled off, mainly just because they're easy, and we talked about before the regulators are kind of general use. Pulled this capacitor off just for an experiment, and this one I pulled off for future use as a 4-element RCA jack or plug, whatever that is. I used a torch to take that off and kind of got a little bit crazy with it, and it caught on fire. And over here, same thing. So I need to refine my technique, but basically I got what I wanted here. So that concludes our tour of this Pansat digital satellite receiver model 2100A. Thanks for watching, and bye-bye.